Hello, hello. There he is. All right, and there he is. Hey, hey. Good morning. Good morning. Wait, sorry. Sorry. Whoa, my goodness. Hold on one second. Sorry. There's things happening in all directions. Good morning, Colin. Good morning, Brandon. Good morning, Brittany. Good morning, Xavier. Good morning, Charlene. Good morning, Alexis. Good morning, Brittany for the double. Good morning, Gaia for the guy for the world. Good. Who else did I say? Okay, people coming, people coming. We'll start in this. Hold on. Oh, more people. Hold on. Uh, once. Uh, uh. So good morning, Judith. Good morning. More people. Okay, okay. I'll just start. Oh, sorry. Yes. Good morning, Judith. Sorry. Good morning, Adenelsi. Morning, Mickey. Good morning, Chanel. Good morning, Ryan. And now, okay, Stephanie. Good morning. Okay. Um. So, all right. Okay. So, oh, and good morning, direct chat person. Okay. All right. So, I think I've gathered that you've gathered that a bunch of stuff was recently put in your Google Classroom. Let me try to. There's one more equation that I want to teach you before the semester ends. I'm going to teach you that equation today. And it was the one for which that very last homework on which the very last homework was based. But I think we've already said that very last homework, the gravity, I think we've already said that that's like super optional, not expected for you to do. But I do want you to know the equation, the concept on which it's based. So that's like the one piece of content that I would like to give you today, the one piece of new content, final content that I'd like to give you today in a few minutes. Um, and Other than that, we're trying to use this week, the last two classes, to tie up loose ends, get ourselves ready, catch ourselves up, which includes me, and be prepared to close down the semester with as much dignity and success as possible. No, no, you're totally not cooked. No, in fact, I feel like I'm trying to say the opposite. Wait, okay, I'm looking at the chat. Okay, wait, sorry. So to answer the questions in the chat, wait, okay, let me back up for a second. So other than the one equation that I do want to spend some time on today, maybe 25 minutes to a half hour, just so you know it and you have a basic concept of it. Other than that, the point of today and Wednesday is to make to eliminate as much confusion or reduce as much as possible any confusion or surprises or uncertainties or anxieties regarding the final exam or final responsibilities or the end of the semester or final grades. Hence, like anything that's in the chat on that topic, I absolutely do want to address today and Wednesday. I mean, I think some of the questions I can already anticipate and have answers ready for. But yes, so bear with me. So yes. So let me prioritize the chat right now. I mean, one question says, "Are we cooked?" I mean, I think that's kind of a joke, but like, no. I mean, hope not. Unless you know something I don't. I certainly don't want you to be. I mean, again, my goal is for you to end up with as high grades as you legitimately can end up with. And even more than that, I want you to end up knowing and liking some physics. Now, I think there's still a very high chance for that to happen in most people's cases. Certainly, anybody who's still tuning into me at this very moment right now. Um, but so one person's asking, wait, okay, wait. Okay, sorry, things are happening. So in, and let me also just remind you that I'm going to try to answer these questions right now and for the next 2 days. But let me remind you again, or I mean, let me encourage you, like, I'm typing in the chat. Okay, so one thing I'm going to try to, because I can see already some of these questions that my cell phone number is again in the chat right now. I encourage you to text me. I mean, I said this like on the first day of class, like this is the time where it matters to some people. I encourage you to text me between now and the distribution of the final with any kind of question that's super concrete, that will take you longer to write the question than it will take me to answer the question. You know, like yes or no questions. Um, um, like can I still hand in a homework or something that would reduce that if you could get a quick and concrete answer would severely reduce your stress. Like that's what texting is for as far as I'm concerned. I'm faster with texting than emailing if I don't have to type a lot. I can't explain a whole unit of physics to you in a text, but I can answer a quick thing. So okay, so I encourage that. So one question in the chat right now is in terms of the game portals, will I still accept them at this point? Yes, I absolutely will. I will not the daily turns. Even though I have fallen very behind on them, you've kept a record of daily reflections, you know, that are date time stamped. They're relevant in that they show that you were plugged into a class, one class at a time. Um, so those, the daily game turns, those are like relevant to each one night. It doesn't make sense to hand in those now, but any of the other game portals, like showing video, you, things like that, sure, you could still turn those in until the last day of classes. So yes, for most of those, it's not that well, I mean, if it's something like I showed video today and you're gonna deposit a few of those, yeah, I think a screenshot of showing video makes sense. Otherwise, it's a little silly. But a lot of the other ones, if it's about some comment where you multiplayer co-op where you helped someone or something, it's not about you proving it to me. It's about you reminding me the specific content. I mean, if you can say, I said this to this person about this point, like honestly, I do have a good memory for things like that. So once you tell me, I'll be like, oh yeah, I remember that day, even if I don't remember exactly what day it was. Okay, so it's not about proving, right? It's about a little document, a little PDF, like the person's asking, where you say a sentence or two reminding me of what it was that you did that day. Okay, so I mean, with video, yeah, you kind of do want to send a screenshot, otherwise it's a little bit silly. Um, Even with video, I kind of do know who it is that's showing video like a lot and who isn't. I mean, not to be weird, but like if all of a sudden you claim that you showed video like every class for 5 weeks in a row and you kind of never did, I mean, I think I know. Anyway, I think you get it. What I'm really trying to say about back homeworks, I've fallen behind too, so I'm willing to be very understanding about getting stuff at this date. Yes. Or old redos. Yes. You can do that. You can deposit them. I mean, submit them up until the last day of our class, which is, well, up until the last day of classes, which is this Thursday, I believe. You can give me stuff up until this Thursday. You can even give me redos on old homeworks. Just understand two things. And I'll happily give you credit for them. Maybe not full credit. Again, we've had this discussion before. You'll get credit for them. But I would say two things. Number one, you see how far behind fell as well. So it's not like I can give you a lot of feedback at this point about old things. I can give you credit, which I'm happy to do, but I can't get into a dialogue about old things at this point, really. I hope that makes sense. So in terms of redos, if there's something that you think you can redo, either based on feedback I gave you a long time ago or based on class notes you have or something like that, sure, go for it. But I can't like invite a new improvement discussion at this point. And the other thing, and I'll move on in a second. I hope this makes sense. Yet, bottom line, I'll accept stuff until the last day of classes. How could I not? Like I'm human, you're human. Um, but it would be a strategic error on your part to dump a huge pile of things on me like the day before the last day of classes. Like, don't now give me all the old homeworks or something like that. It's just not wise. It doesn't serve you to do that. To suddenly give me a disproportionate amount of work to look at of yours as an individual when there's 80 students. I, I think you get the point. So it's sort of be careful and wise. Again, if you were trying to get points at this point, any points you can, um, I respect that. But I would go in backwards order. Deal with the most recent things first because they're most likely to help you follow what's going on this week or follow the exams, the final exam, or be prepared for Physics 204. Going back to super old stuff, you won't get as many points and it won't be as good a use of your time. Um, so I hope that's sort of clear. Obviously, I do want to talk about the final exam and all that in a minute, and I will. But there was one other thing on this whole subject of homeworks and stuff. Um, yeah, I can't remember. Oh, wait, I'm just looking. Yeah, so last things of old homework and stuff like that, you have to the last day of classes, as far as I'm concerned, to hand in. Okay, but again, be sparing and be be selective. I would put whatever time you have to spend to catch up to, I would spend it more on trying to get ready for the final. Wait. Oh, okay. Now, sorry, there's another stuff coming in. Uh, bear with me for 1 second. I see there's more in the chat. Hang on 1 second. Um, okay. Well, okay. So there's something in the thing about the final you're posting. Right. Okay. So let me talk about the final now. Because also my impression is, for good or for bad, I think you all do now have your midterm scores back. So okay, so that's good, right? I mean, it's bad that it took this long, but it's good that you have. Um, okay, so the final exam, yes, it will be posted by no later than 8 p.m. this Friday, maybe possibly earlier, but like that's my outside, and you'll obviously be notified if it's posted earlier. Um, but no later than this Friday, 8 p.m. And then you'll have till midnight of Tuesday to do it. So yes, so that's just like the last one. You take it home, it's open universe. So I hope you can see from, so yes, the answer is, and hopefully you saw, I mean, the person who's asking in direct chat, I'm gathering from that question that you see that there's announcements and stuff like this in the Google Classroom. So if what I'm saying, if I'm speaking too fast right now or anything, like it's all there. You can double check, and anybody should triple check right now to make sure I'm not saying something that's contradictory to what's in your, your system. But yes, exam posted this Friday, due back midnight Tuesday, and then that's it. That's the end of the semester. Then for some people have been asking, then what happens is, okay, I'm all over the place. Um, First of all, okay, I think the midterm scores were for the most part good. I don't think for the most part anybody should be panicking or something like that. Um, hope hopefully you could tell. I hope it sort of became apparent in some of those scores, like where people didn't get 100 and nobody got 100, but like wherever you do lose points, I hope you sort of see that part of the thing here is like, yeah, we're looking for a thoroughness of explanation and derivation, and we're looking for you to guide us through the solutions. Same thing on the final. Like, it's sort of, we're trying to get it clear that, like, just knowing the answers from a website or from another person or from me or from my videos, like, just knowing the answers is not in most cases sufficient. It's really about understanding how to walk through the physics. That's what you want to do for the final. I again, I will address the final more specifically in a moment, but as a larger picture, um, how do grades work? Because now they're getting more concrete. I'm sure you're thinking about them. I'm sure you're concerned about them. Couple of things to say about grades. One thing is, it is fair to assume that the numerical score that you got on your midterm is not the letter grade that you're going to get in this class. It's in most cases, it's fairly fair to assume if you've been hanging with me, if you've been in class for the most part doing homework, if you've been going to lab and doing your lab reports and all that kind of stuff, right? Now, of course, I don't directly know what you do in lab, but if you've been a holistically invested student, in most cases, what you end up getting as a final letter grade is like any is higher than the numerical score that you got on your first midterm. In most cases, I'm not making any promises here, but just so that you can have a sense of where you are, like, um, if you got a 74 on your midterm, that does not mean you're getting a C in this class. If all your other ducks are kind of in a row, not out of control, amazing, but kind of in a row, you're by the time we factor in your lab and all your homeworks and all this game participation stuff, and then assuming that you do reasonably well in the final, your final average is probably, if you got a 74, I'm just spitballing here, but if you got a 74 on the midterm, right? Your final average in this class is more likely something like an 82 or something like that. Okay. If it looks like a C, you're probably more in like the B minus land once everything else is factored in. You should know that. You shouldn't get complacent before the final, but you also shouldn't be panicking based on the number on your document. Okay. Usually your final grade is like approximately a grade higher than whenever you got there because of everything else. That's assuming that you're doing everything else. Um, to be more specific now about that, to be more specific about that, um, what I usually do, because as you see, I'm always a little bit behind the eight ball, and I'm always behind the eight ball with all of these numbers and putting everything together. What will generally happen is, you may want to make a note of this. I don't know. Your exam gets submitted Tuesday by midnight, Tuesday of next week, right? So that's the 13th. I'm sorry. I mean, that's the 20th, right? Just so you know, your final grades are due to CUNY first by 11 p.m. or something, Tuesday the 27th. Like a week later, the grades are due. Now, usually that week is somewhat intense and miserable for me, the intervening week, right? And it doesn't help anybody for me to get very involved in any individual situations for too long during that week. But that's the week that I spend doing all the final grades. They will be posted on time, but they won't be posted early. I mean, you should expect them somewhere around Tuesday, the 27th. You should know this in case it's not clear. Number one, I cannot post one single grade until I have all of the grades ready to go. Like they do that on purpose, like literally, even if I wanted to. It's technologically set up that it won't accept my grades unless I'm ready to hit submit on all of them. I mean, for good or for bad, that's true. Um, so the grades will not be posted until Tuesday night, the 27th. You should know that. But you should also know that 99% of the time, what I've been doing for, unless something really goes awry, what I've been doing in prior semesters, in recent prior semesters, is I will post a spreadsheet to you all, like around a day in advance, like around the Monday, the 20, Memorial Day or something like that. Look out for, you'll get a spreadsheet with your grades, with your entire breakdown, with everything fully submitted once I have the finals done and all that. You'll have everything in a spreadsheet. You'll see exactly how your final grade is computed, and you'll sort of have a chance to see it once in its full explanation, or its full breakdown before it goes to CUNY first. If there's any issue or problem or question, you have a little time to notify me. So please know that, like, until that, so about Monday or so, a day in advance, you'll see what's going on before it goes official. I mean, even if it goes official and there's like something hideous, I can always submit a grade change form, but you'll know before it goes official. It'll be tight, but you'll know, and you'll have a chance to ask me a question or protest something if you think I made an error, which I certainly am capable of. But that's why I do that. Okay, so if you have again, the grading system is, I mean, it was explained at the beginning of the semester. It's like in the syllabus and all that. I don't want to and it will be the same for 204. Those of you who are joining me for 204, like, your investment in this class will be worth it in that regard. Um, but everything will be clear like about a day or so before it goes in. So you have a chance to see how it all worked. Again, all of your homeworks and all of that stuff amounts to extra points on your average at the end of the day. And your lab factors in as with equal weight to your to the two exams. I hope that sort of makes some sense, but that's like the sequence of how that will go. Um, I the final exam itself now, wait, I'm just looking at this. Okay. The final exam itself, I still, frankly, have to make some decisions of exactly how I'm doing the final exam this time. But what you've now seen, what many of you've noticed, there's an exam from last year available to you in your Google. The final exam from last year is available to you in your Google Classroom. Now, just as of this morning, I posted the exam from last semester. They're a little bit different. They are different. I'll address that in a moment. I think you should be aware of both documents. Uh, our final exam, I'm going to pull ideas from both of those documents. I'm not exactly sure fully which way I'm committing yet. You should be prepared for anything in either of those documents. I'll be more specific again in a second, but both those documents are available to you for a reason. You should be prepared, you should be prepared for any kind of thing from either of those two documents to happen. My understanding, correct me if I'm wrong, my understanding is that you have a review session, that lab tomorrow. You have lab tomorrow, I think. Tell me if I'm wrong. I think you have lab tomorrow. Is that right? You've Do you have lab tomorrow? Yes, great. Okay, thank you. So my strong understanding is that in that lab period tomorrow is going to be preparation for the final. Mercedes will do anything and everything she ever usually does and can to help you be and feel prepared for the final. You are welcome to let her know that I have said to you that the final could take material from either of those two documents. I mean, obviously, she has seen those documents many times. She's seen everything in those documents many times. I mean, of course, she taught last semester and all that. But I'll tell you right now, and she's been apprised. I told her I'm a little bit betwixt and between whether I'm going to do it like I did last semester or like I did it last year. You'll notice there's slight differences. She's aware of that. Um, I think as of this moment, she was probably planning more to go over the document that's been sitting in Google Classroom all semester. But I'm telling you right now, and I will tell her that I did tell her actually, but you can remind her that the other document that I just made available to you is also fair game. Okay, so however she and you guys want to use your time tomorrow, that's up to you. I'm not trying to keep you in the dark. I'm just being honest that I want you to be prepared for all of this material. And I'm not exactly sure. Like on your final exam, you're going to get choices just like you did in the midterm. You're going to do like a couple of problems. I don't have time to grade more than two, probably. You're probably going to do two problems, but which two they are will be somewhat up to you, but somewhat up to me as well. So now I'm going to be even more specific, and I'll shut up in a second because I know I'm saying a lot. I just want to get this all out so there's no mystery or whatever. Okay. I mean, the point is to know physics. The point is not to have a guessing game. Um, so, so if you look in the exam from past years, the exam very heavily emphasized this whole inclined plane comparison idea. Like it's very much like Lab 5, which is why I talk about Lab 5 a lot. But then it asks you to look at Lab 5 from a different reference frame, which is a way of not only forcing you to understand Lab 5 better, but also to tie in this whole Galileo principle of relativity theme, which is a huge theme in physics, not only for this course, but for your future course as well. So, what a standard exam in this course often gets very involved in that inclined plane, and that is a possibility. It is very possible that I'll ask you a big problem about the inclined plane, which I'm happy to answer questions about over the next 2 days. But like, and if she goes over it in the or if you all spend a lot of time talking about it tomorrow, that is a terrific use of your time. It's very legitimate. It's distinctly possible. It's one of possible things that would be on the final, and you need to learn it. So even the preparation and the studying is like part of your is part of your final experience. Okay. But just like in any class, often you study a lot of stuff and then like some of it appears on the final and some doesn't. You never know. I don't, so that's one possibility is that there will be a huge emphasis on the inclined plane in your exam this Friday. Another possibility, as you're now seeing, another possibility, I mean, as you saw 20 minutes ago when I just posted it, is that I may, as a choice or a requirement, I may ask you to redo a problem from your midterm, whichever problem you did the weakest on. I may give you an opportunity or a requirement to just like literally redo your weakest problem from the midterm. It that is partly in recognition of the fact that you've been waiting so long for them. We like they shouldn't just go into like all your patience and your flexibility and your study and your preparation for the midterm should not just go to waste. Like you should have an opportunity to do something with all of that. So there's a distinct possibility that one of your problems on the final will be, sorry, I'm just changing the viewing screen, will be like redo your weakest problem for the midterm. If you do that, or if I do that, if that's the case, again, sort of a pro tip or a warning or whatever is, I'm aware that in many, many of your cases, even your weakest problem, like maybe you didn't even get that many points off, or maybe there was only minor things. I want to warn you or remind you now, if I'm asking you to redo a problem as part of your final exam, I need you to literally redo it. Like, don't just submit a minor typographical correction here and a minor typograph and then call that your final exam problem. I mean, you're going to do it again from start to end. Like you should submit something that stands on its own, that is super solid and super strong, that I would view as that should be even better than your other problem, even if I'm not looking at your other problem to see that. I hope that makes sense. Having said that, I'm still going to ask you to submit both so I can look at both and look at the improvement. But it may be a relief for some of you to get a chance to resubmit an old problem. If it is a relief, I'm glad. I mean, if that makes you happy, that makes me happy. But don't think it's a joke. I mean, it means you know the work well enough, pretty much from the last problem, that you're willing to undertake that work again and just make it an even better draft. Okay, so that's a possibility as well. The last possibility that could be on this final that you'll notice from the document that you just, and again, stop me if I'm just talking. I hope you know what I'm talking about. Like, yeah, you do. Oh, great, great, great. I'm seeing. Okay, okay. Like in the document most recently uploaded or made available to you this morning, you'll notice that something else that happens in that last semester's final exam was I gave a problem about springs and energy, which happens to be, it doesn't have, which is the first homework assignment for Physics 204. Okay. Now it's based on the material that we've been studying here in class about work, energy, springs. We've actually done a better job, believe it or not, of covering that material with you than sometimes in the past we have. And I'm happy to answer more questions about it. But that it is a possibility that you would work through that spring problem as one of your problems. We haven't it hasn't been a direct homework. It is a look ahead to a homework that many of you will be assigned right at the beginning of Physics 204. Why am I saying that? I'm saying that it's an option. I don't know which of these three. Maybe I'm going to put all these three things on your final and ask you to choose two. Maybe I'm going to put all three and say you have to do one, but then you choose the other. I'm not sure yet, but you should be ready to do the spring problem. You should be ready to do the inclined plane problem. You should be ready to redo one of your old problems. Like you should be ready for any of that. And you can use Mercedes this time, like however, or you and Mercedes together tomorrow, use your time as how is best given all of that. As far as that spring problem, that that is the first homework problem in Physics 204. I'm not giving out answers to that or anything like that in advance because I'm not, but I will tell you if you've gotten used to the YouTube channel at all, for sure. If you go to any playlist called Physics 204, such as Physics 20, the playlist of Physics 204 from this semester, fall of 2025, for sure, I go over that problem in great detail, like for the first like 3 weeks of the course. Like I go over it a lot. You're welcome to look at those videos and see, like, you're welcome to see how I did that if it helps. Again, just know that I know that you'd be doing that. So make it as clear as possible that you now understand the physics as well as possible. But yes, I'm just about done now. One possibility for your final is a look back, look ahead situation where you're asked to fix stuff you did from the midterm so that that all ended up meaning something to you and benefiting you, and you show improvement as a physicist. And you may get a glimpse ahead of the first bit that we do in Physics 204, which if that ends up being on the final, it's meant to really help you hit the ground running when we start that course. Obviously, not all of you will be in it, or not all of you will have me, but that is a possibility that the final involves some look back and some look ahead. Okay, sorry, that's like a big speech. I'm going to take a breath for a second. Does that make, am I making any, can I just get like a show? Does that make any sense? Is that clarifying at all? Do you have any, I mean, do you feel any sort of like intuitive, um, do you feel that the expectations and the next couple, good, thank you. Okay. I see in the direct chat. Okay. Oh, I see two things in the chat. And okay. All right. So good. Thank you. Uh, Again, you can come back and ask me questions about any of that over the next 2 days. There's always my hope is for you to be calm and strong in your entire, not just in my class, in general, these next 2 weeks. As calm and strong as you can be is great and makes me happy. Ironically, as you can see, I tend to not be very calm during these periods of the semester. That doesn't help anybody. I apologize. But um, but that's because I want you to do well, and I want myself to do well, so I get jittery. All right, oh good, oh great, thank you. Okay, all right. So as questions occur to you about, and you'll probably have more after tomorrow after you see Mercedes. So last day of class Wednesday will be super wrap up, like super. Maybe I'll even have more whatever. It'll be just about let's make sure we're as good to go for the final as possible. So you may have more specific. So I do encourage, I mean, keep track tomorrow while you're with Mercedes. If there's things, physics matters you don't understand, or logistical matters you don't understand, bring them to class on Wednesday to our last class. And the more short, concrete questions the better, right? The more questions you have that can be answered concisely by me, the more I can help the more people. Okay, so hopefully you'll come with concrete questions Wednesday. For now, I mean now then, I want to give you one last equation, and I'm not going to dwell on it. And it's this. So let me explain what I mean. Okay. I, I want to remind you that something we have emphasized in a big way in this course so far is Galileo's principle of relativity. It is my strong, in my experience, in my perspective about physics, physics is about perspective. And I mean, classical physics, it begins with Galileo in the early 1600s, let's say, or late 1500s, and up even through Einstein of 1905 into the 20th century. The principle of relativity is the fuel in the tank of physics. I mean, I'm not making this up. Like, obviously, some other people like some other ideas, maybe a little bit more, whatever. But I think it's a fairly widespread understanding that physics rests on the principle of relativity. That's why there's so many different ways to say it. That's why there's so many different implications. My belief is that every topic of physics that we ever study in some way is a new expression or a new emphasis on the principle of relativity. In this course, we've already learned like seven forms of it. And each one of those forms is kind of like a different sub chapter of this physics class. There's more forms that come down the road, and therefore more topics of physics. I mean, including physics 204 and beyond. The heart of Galileo, I mean, the sort of original way to say it in English is that the laws of physics are the same in all unaccelerated reference frames. But if you want a really informal or really sort of almost historical way to put that, it is that the Earth is not special. Like when you really get down to it, um, Galileo's principle, and I got very excited about this like a month and a half ago or something in some lecture with you. Oh, and when we talked about train of thought and all of that metaphor, you may recall that the principle comes into the discussion in the first place from Galileo in Galileo's attempt to say to everybody, this idea of Copernicus or this way of looking at the world, most recently from Copernicus, this way of looking at the world where we don't put the earth in the center and rather we have the earth moving around the sun. This may not just be a clever way to get rid of some of our math headaches, but there may be really something to this idea that Earth is not sitting still at the center of the universe. Like this is Galileo's revolution. Again, he's not the first person to ever consider this idea by any means. But in a way, he's the first person to sort of demand that we take it seriously as a significant physical truth rather than just as a mathematical device. He's saying, guys, really, when you view the Earth as as a stationary body at the center of the universe, that's a perspective that you have that might even be convenient at some times, but it's just that. It is a perspective. It is not a better perspective than many others. It's not more objectively accurate than many others. It is not the ultimate truth. What is not the ultimate truth? That the earth is special somehow. That is what is not the ultimate truth. And this is revolutionary to say that the earth is not special, that it's just another rock hurtling through space, like a bunch of other rocks hurtling through space. Like that's the original big deal of Galileo's principle of relativity. Or put another, for our purposes in this course, to say there's no actual zero velocity case. Like we used to kind of think that velocities were like objective measurements. An object has a certain velocity or it doesn't. And if any, and you get my point. We used to think that zero velocity was like a thing that like the Earth had. Earth has zero velocity. Something sitting on Earth has zero velocity compared to Earth, and therefore has zero velocity in the universe. Like objectively, that's what we used to think. We don't think that anymore since Galileo, and I know you know that. But part of this not thinking that way anymore is knocking down the idea that the Earth has any kind of special property that any other rock in space doesn't have. Okay, I'm repeating myself, but so what? So what? Well, so all the physics we've been doing recently treats Earth as not special. Okay, that's what I'm trying to say. Except in one respect that has not yet been addressed in this class, which is that is is the 9.8 number. Like I I'm saying over and over, and hopefully you've gotten a theme that there's nothing special about the Earth. It's just a rock going through space, just like Mercury or something. But then, but then why does Earth seem to have this special property that it pulls all nearby objects to the center of it? Always, like, why is Earth pulling on everything toward it all the time at a constant rate of acceleration? Like, why is there weight in the first place? What if you get my point? I'm saying on the one hand, Galileo's saying Earth is not special, but then Galileo is the one who even figured out the constant acceleration due to the center of Earth. And Galileo is the one that made all these inclined planes and everything. I should quickly say one of the reasons the inclined plane is such a big deal. It's that's it's not just that we use mg and mg sine theta and everything to analyze the inclined plane. It's that it's the inclined plane where we got the g number from in the first place. Like, because things fall too quickly. I mean, people didn't have stopwatches in the 1500s or the 1600s. If you think, and even if you've heard about these experiments where Galileo went to the top of the Tower of Pisa and like dropped heavy objects and light objects, and by the way, I do believe that that happened, but I believe that happened. I mean, people tend to believe that that really happened, but I'm getting off that was to make comparisons between objects. Even if you stand at the top of the Tower of Pisa, in the 1600s, nobody has watches precise enough to catch the amount of time that it takes an object to fall from the top of the tower to the bottom. You could compare the time to another object, but to actually know the time with enough precision to infer 9.8 as the rate of acceleration, no way. Like that is not a thing. What did they do? What did Galileo do? He made inclined planes and diluted gravity. He slowed things down on purpose, like you did in the lab. And that's how he figured out the 9.8 number, just so you know. I mean, so the inclined plane is like a very big deal. And 9.8 is a very big deal. But 9.8, which comes from Galileo, seems to contradict the whole Galilean program that says Earth is not special. Do you see what I'm saying? So how do we resolve that? What's going on with that? Well, it turns out And you probably see where this is going, or you've probably heard this before, but maybe you didn't think about it in this way. Hold on. Um, okay. The person who resolved this seeming specialness of Earth was Newton. Now, remember, please, again, if we're trying to put this course together or summarize this course, remember Newton's first law and Newton's third law. In my experience and from my perspective, Newton's first law and Newton's third law are themselves restatements or new developments of Galileo's original principle of relativity. Like, okay, I won't get bogged down in the whole discussion right now, but Newton is very consciously picking up where Galileo left off with this idea that zero velocity case is not special, it's a matter of perspective, right? That objects have just as much of a hard time slowing down as they do speeding up. Wait, I said that in the reverse. You know what I'm saying. Um, and that and that forces are symmetrical relations between two objects, just like velocities are symmetrical relations between two objects. Newton is picking up on the Newton is picking up on the Galilean program and then making it more mathematically rigorous and more extensive. In addition to his three laws, he establishes another law of physics, which has law status, although so it could have been called the fourth law, but it's not. It's the law of universal gravitation that I imagine many of you have heard of. And it goes like this. It says, okay, here's a given. Imagine there are two point masses separated by a distance r. You could call it d, maybe, and in some cases, some people do. We tend to call it r because ultimately the letter r connotes radius, which ultimately becomes very important when you're talking about gravity and orbits and things like that. But so imagine that M1 and M2 are point masses. That means they're little dots of mass. They could have any amount of kilogram each one. M1 is a very big point mass, let's say, and M2 is a very small point mass, i.e., M1 is like a huge number of kilograms, let's say. M2 is a small number of kilograms, but each one is a point with regard to volume, right? So these are, you might say, idealizations. Although they're really not idealizations because it turns out electrons, for example, are point particle, are point masses. So imagine like a heavy thing over here that takes up an infinitesimal amount of volume, and a heavy thing and a less heavy thing over here that also takes up an infinitesimal amount of volume, right? So little particles that are separated by a distance r. According to Newton's universal law of gravitation or law of universal gravitation, Okay. According to this law, this discovery, if you like, if you have any two bits of mass anywhere in the universe separated by any distance at all r, one bit of mass will automatically exert a force called the gravitational pull onto the other mass. And according to Newton's third law, the other mass will also automatically exert a pull known as gravitation on the first mass. It is a pull, it is a force like any other in physics measured in newtons. It is a force that contributes to F net equals ma, like it would go into it'd be plugged into the left side of F net equals ma and thereby contribute to acceleration. Um, it is directly proportional, this equation is saying that the magnitude of this force, oh, hold on. Okay. The force is a force like any other force. All forces are either pulls or pushes, right? Every single force in the world is either a pull or a push. This one is always a pull. It's always a force of attraction. I mean, you know this. But what we're saying right now is that it's automatic. We're saying if you exist as a mass over here, as some bit of mass, and then on any and every other bit of mass anywhere else, you are automatically pulling on the other mass with a certain amount of newtons. The certain amount of newtons that you're pulling on the other mass is directly proportional to how big you are, how massive you are, directly proportional to how massive the other object is, and it's inversely proportional to the square of the distance between you and the other mass. The constant of proportionality is this number, capital G, not lowercase g. It's not 9.8. Capital G is a constant of proportionality that is a universal number, happens to be, as it says down there, approximately 6.67 times 10 to the negative 11th newtons times meters squared divided by kilograms squared. Okay. So on the one hand, what I'm saying is numerically, mathematically, if you know if you know the number of kilograms that some mass is, and you know the number of kilograms that some other mass is, and you know the number of meters between the two masses, then you can compute the number of newtons that this mass is automatically exerting onto the other mass, like the strength with which the first object is automatically pulling the other object toward it. As long as you know the mass of each, the distance between the two, and you know this universal constant to plug in. Am I asking you to memorize the constant? No, I'm not asking you to memorize it. Why am I saying? But I'm asking you to be familiar with it and recognize a couple of things about it, such as it's really tiny. It's 6.67 times 10 to the negative 11th newtons meter squared per kilogram squared. Recognize number one, that's really tiny. Recognize two, that whatever the number is, the reason you don't have to memorize it is because you can always look it up. And the reason you can always look it up is because it never changes throughout the whole universe. It's always the one same number. Number two, or number three, notice the units. You might think the units are really obscure and weird and hard to memorize. Newtons, meters squared divided by kilograms squared. But in fact, if you look at those units, you'll actually understand, you'll see that the reverse is true. The units of that weird number are totally logical when you think about it. The units have meters squared in the numerator to make the meters squared in r squared cancel out. They have kilograms squared in the denominator so that they cancel out with the kilograms times kilograms that are in the numerator of this equation. And then what's left after all that is just newtons. In other words, that number just is literally like a constant of proportionality, or if you like a conversion factor. It's only there so that once you multiply kilograms by kilograms and divide by meters squared, then we end up getting a quantity that stays in the metric system of SI units. And we end up getting a quantity in newtons. If we were willing to measure in other kind of like units of measurement or something like that, or whenever we do measure in feet and pounds and things like that, then this number is different. It's not so it's just a conversion factor really to make the units work out. So don't get hung up on it. What you should get hung up on, what we get hung up on, is the rest of the equation, the dependence. We are saying from here on in, anything that's in the universe, any bit of mass that's in the universe, well, here, let me write this down. Sorry. What I want to make clear here about this, I mean, yes, the equation is a math equation. Yes, it allows you to determine the magnitude of the gravitational attraction as long as you know the magnitudes of the two masses involved and the distance between them. But conceptually, there's some deep implications of this as well. I mean, not just the numbers. One thing is what we're saying from here on in is that this idea of gravity is fundamental. It's the first example in a list of what we might ultimately call the fundamental forces of physics or the fundamental interactions of physics. This is the first one that we are mentioning as a group, but also sort of the first one that is looked at that way in history. What do I mean by fundamental? I mean, first and foremost, well, I mean everything, every bit of math, all you have to do in order to enact this force is be some amount of mass, right? For, uh, um, right. First of all, so I'm saying, first of all, the Earth is not special. I'm saying that, or Newton is saying, the earth pulls things toward it because, in fact, everything pulls everything toward everything. That's the first thing that we're saying. I mean, and from that alone, you might wonder, well, why does the whole universe not just like collapse in on itself? I mean, if everything is pulling on everything all the time, which I am saying, which Newton is saying, every bit of mass is pulling on every bit of mass in the universe at all times. We are saying that. However, what we're not saying that there aren't perhaps other fundamental forces that are also doing some pushing. We get to that in physics 204. I mean, there are other forces, it turns out, in the universe, such as electrons push on other electrons. Okay, for example, big example in physics 204. So we're not saying this is the only universal interaction. It's just the first universal interaction that we look at. But we are saying it's universal. So whatever property the Earth seems to have to pull things toward it is not a property of Earth. It's a property of the Earth's mass, of which the Earth has a lot. And the Earth is very close to us, right? So if you look at the equation, G, for a minute, this equation, this equation, it starts to show why we're always like affected by the Earth's gravitation, because the Earth is like a mass of 6 times 10 to the 24th kilograms, and it's right underneath our feet at all times. So the pull from the center of Earth is far more relevant to our lives every day than, say, the pull of Jupiter, which is, or even better, Jupiter, which is really, really far away, or Mercury, which is somewhat close but really small. Like, right, the Earth is a big, close rock, so we are affected by it, but not exclusively, and not for special reasons. That's number one. So when I say a force is fundamental, I mean all. So then this is what I mean by statement number one here, where it says no action required. What I specifically mean is, in order for a mass to enact a gravitational pull, what it needs to do is nothing. It just needs to exist, right? Like as opposed to friction, like one surface has to rub up or press up against another surface in order to enact friction. Like there has to be velocity, like, for example, or things like that. Like most forces that we've studied so far, or for the tension in a rope to pull something, the rope has to reach out and grab that thing. With gravity, you don't have to do anything to make gravity happen. As long as you exist as a mass, you will exert gravity. That's point number one, way in which it is just fundamental. Point number two, and again, this becomes like important in physics 204 for what it's worth, but in life too. Point number two is action at a distance, meaning that R in the denominator of this equation, that R is the space between two objects, and that R really can be empty space. What I mean by that is, like it turns out the sun exerts gravitation on the earth, as I think you've heard in your life, and pulls the earth towards it and keeps the earth in orbit around it. The earth, exerts gravitation on the moon and pulls the moon toward it. Not only is the earth like quite far away from the sun, like 93 million miles, and not only is the moon less far, but still quite far away from the earth, like 250,000 miles, but the moon is separated from the earth by nothing but empty space, by a vacuum. In other words, somehow the earth can pull on the moon without touching it at all. That's what I mean by action, or that's what people mean by action at a distance, that even over a distance of empty space, somehow masses seem to have the ability to affect other masses. That's interesting, I think. I think people think. That possibly raises as many questions as it does answer questions. Possibly some of those questions are for physics 204. But what we believe is that not only do you not have to do anything to exert gravity, you don't have to touch something else in order to pull it gravitationally. Conversely, there could be stuff in between the sun and the earth, or the earth and the moon, or between the center of the earth and, like, a brick that I'm holding right here above the ground. There could be stuff in between, and that stuff doesn't stop the gravity. Do you know what I'm saying? Um, well, yeah, like, I mean, if I hold an object above the desk, above the ground, the floor, like we all know, if I let this object go, it's going to come crashing down to the floor. Even though you can't see, but even though there's a desk in between the floor and the bottle, well, and not only that, the floor itself and a sea and all this, there's all of these things in between the center of the earth and this bottle. But if I let the bottle go, it's going to fall down. In other words, it doesn't require any material objects to transmit the force of gravity from the earth to it. And furthermore, no material objects seem to be able to block the force of gravity from the center of the earth to it. And let's be clear again. Sure, right now I just put the bottle back on my desk. Like so the desk is holding the bottle in place. But remember the free body diagram. It's the desk is holding the bottle in place because there's a downward force of mg on the bottle and there's an upward normal force from the desk. So the upward force is fighting the downward force and there remains no net force. Therefore, the object doesn't accelerate. In other words, what I'm saying is it's not that the desk makes the mg vector go away. It just counteracts the mg vector. The mg vector, gravity, the weight of the object, it seems to be there, coming from the center of the earth, whether there's empty space in between the bottle and earth or there's stuff in between. Gravity is action at a distance. That's what I'm saying and that is a hallmark of a fundamental force. In fact, there's a last. We're actually going to go. I just want to expand on that. Maybe some of you hopefully wrote this down already, but okay. So just to expand on what I mean by action at a distance, an action at a distance is without exception is the hallmark indicator or property of a fundamental force. And again, let me remind you, you know about a lot of forces in this class already. We talked about the normal force, the frictional force, the tension force in a string. Those are all forces. This is the only, but they're not fundamental. They're um they're like macroscopic manifestations of complicated microscopic phenomena. This one is fundamental. And by fundamental, I ultimately mean action at a distance. And by action at a distance, I mean these three things, really. I mean that there doesn't need to be material contact in order to transmit the force. Like you could just transmit it through empty space, and you do always. That no material object can block the force. I mean, so it just happens. Like you see my point. It's just fundamental. As long as two masses exist, there is gravity between them. If three masses exist, there's gravity in all pairwise directions that you can conceive of. But then finally, just note, and we're going to actually end here. Believe it or not, we're actually going to end early today, unless there's any question. Well, I'll leave 5 minutes for questions if there are any, um, but I'm not going to overload you today. But the last thing I want, oh, so now literally someone leaves right when I say that. I mean, wow. Okay. Um, um, Notice the last bit of mathematical reference, which again is sort of like a foreshadow to Physics 204. An action at a distance force. it happens through a distance, but it's distance dependent. Like action at a distance forces do get weaker as objects get farther and farther away. Otherwise, everything would be pulling on everything with equal amounts. And that, like, then the sun would have the same effect on us as the earth has on us as the moon. I mean, that would be chaos. Forces action at a distance, the gravitational action at a distance does get weaker as two objects get farther and farther away. And it gets weaker as a function of it's, in other words, directly proportional, it's inversely proportional to the square of the distance between the two objects. Now, this is like a funny bit of mathematics or unexpected or unusual. We've certainly never seen this before. It may seem sort of strange. It is sort of strange. It turns out that there are other actions at a distance in the world as well, such as electrostatic interactions, and they too have this inverse r squared property. So there's actually something going on with this inverse r squared dependence that does tend to be associated with fundamental actions at a distance. We'll learn about that in Physics 204, but that's what I just want you to know for right now. So I'm actually done for today. If I'll hang out for a couple of minutes, but you're welcome to leave 4 minutes early for the first time ever. Or if you have any last questions or concerns, yes, thank you. All right, thank you. But if you have, but I'm turning off the recording, but I'm here if there's any last questions or concerns or anything until Wednesday. Have a good day. Yes.